All right, good morning, everybody. So welcome to CISC 124, Introduction to Computer Science number 2. So for those of you who don't know who I am, I'm Dr. Burton Ma. My office is in the Goodwin building in room 754. You don't want to look for me this week because the elevator's out and you'd have to walk up 6 flights of stairs. So if you want to try to meet with me, you might want to wait till next week if you need to see me during my office hours. My office hours are in person in my office. I haven't posted the hours for them yet, but they will be on OnCue when I've decided on what they'll be this term. If you need to email me for some reason, I would suggest that you try to avoid emailing me if you can, because there's so many of you and I teach more than one class. But if you do need to email me, so in other words, try to see me during office hours, or try to see me after class or before class, or try to talk to the TAs, and I'll explain that in just a second. If you do need to email me, make sure that the course code is somewhere in the email. This goes for any email you send to any professor, right? Most of your professors, well, many of your professors are teaching more than one course. They probably don't know who you are by name, and they don't know which course you're in. Or you might be in 2 of their courses. Which is probably the case for many of you here, because there's probably a few of you also taking CIS 220 this term. So make sure that the course code is somewhere in the message so that we can figure out what course you're in. That's my email address if you do need to email me for some reason. Don't try messaging me on Teams. I'm probably never going to see the message because I'm on many different teams, and it's just a lot of information to keep track of. All right, so there are 8, I think, teaching assistants for this course. There are I think there's almost 400 of you in this course. 300, 400, there's a lot of you. There's a lot of you in this course. So there's 8 TAs for the course. Their contact information is on OnCue. They have weekly office hours on Teams where you can just jump in on the general channel on the CIS 124 team and go talk to a TA during their scheduled hours. So that information is on OnCue. It's on the front page of the course, OnCue. For the TAs, generally, I think most students use the TAs to ask questions about the assignments. I guess some students might ask them about the course material as well. The TAs don't know anything about the administration of the course. So if you're asking things like, when is the midterm, or what's on the midterm, or when will the midterm be returned, or something like that, they're not going to know the answer. Course information. So basically everything is on OnCue. I will go over the course information in just a moment. I generally record the lectures, well, at least I try to record the lectures. The recording technology we have in the lecture rooms is not super reliable. Sometimes the audio doesn't work, sometimes the video doesn't record properly. But I try to record the lectures. I do post them eventually, so they don't go up like right after class. They go up when I have time to post them. And they go up on YouTube on a playlist. And so that information will also be on OnCue later this week, as soon as I start posting lectures for this course. For this course. If you want to, there are old playlists. So for every term that I've been, I don't know how many years ago this goes back now, but there are playlists for previous versions of this course if you want to look at the older lectures. All right, textbooks. So you do not need to buy a textbook for this course. If you want to, you can go buy one. There's many Java textbooks that would be suitable for a course like this. Oops, sorry. Instead, I'm going to show you, so there's a bunch of online notebooks that have been written for this course. I'll show you those in a moment. If you want a textbook or some other reference, of course, there's the internet. But there are many books that are intended for learning how to program in Java. Literally hundreds, if not thousands. So I've got 3 listed here that the library has. They are available to you for free. The electronic versions are available to you for free. You might be able to find a paper version if you really want a paper version somewhere in the library. And of course, if you want to, you can go buy these from Amazon or wherever you want to buy, wherever it is you buy your books. Let's see. The last one is not really a textbook. But if you're going to do any professional programming in Java, the last book that's there is highly recommended. The other 2 are pretty reasonable textbooks. Grading. I guess this is, I just want to quickly go through everything here. All right, so I guess the easiest way to do this is on OnCue. Okay, so if you go to the CISC 124 OnQ under content and the course description, you'll find most of the relevant information for the course. So the syllabus is all here. Textbook is here. Grading scheme. So this is the part you're probably most interested in today. So I made a change to the grading scheme this year, or this term, sorry. It's a little bit different. We're going to see how it works. So there are 5 assignments this term. Each is worth 7% or less. I'll explain the less in just a second. Right, so the assignments are programming assignments. You write some code, you submit your code on OnQ. There are 2 tests during the term. They are written, so they're in class, and they are written on paper. They're both worth 17.5% or less. And then finally, there is an exam, which is also written and on paper. It's scheduled by the exams office. It's worth 30% or more. And so the way this works is that your exam grade will override any other grade if the exam grade is higher than the other grade. So you might have some assignments that are worth 7%, you might have some that are worth 0, right? You might have a test 1 that's worth 0 or 17.5%, you might have a test 2 that's worth 17.5% or 0, right? The exam grade will override any other grade as long as it's higher than your other grades. I should warn you, if you're thinking that you're going to take the 100% exam, that for almost every student, this won't help you. So that's just the way it works in this course, right? The exam is typically the worst assessment that's performed by the students. Okay, late assignment policy. So this course uses a 3-day universal accommodation. So that means every student gets 3 extra days to do their work. No questions asked. You don't have to email me saying it's going to be late by a day. You don't have to fill in one of these academic accommodation forms, right? Everybody gets 3 days. So there's an official due date for the assignment. And then there's the date where the assignment closes, right? So the date that the assignment closes is 3 days after the official due date. You can submit your work as many times as you like on OnQ, right? So you can submit your work before it's due and then decide, oh, I want to change something, just resubmit it. Don't email me and ask me if it's okay to resubmit it. Just go ahead and do it. As long as OnQ is open for assignment submissions, you can submit your work. Okay, so there are 2 tests. There are no makeup tests. So if you miss a test for some reason, whether it's you slept in or you're sick or something else has happened, there's no makeup test. The weight of the missed test simply goes to the exam. Right? If you miss your exam, that is subject to the Faculty of Arts and Science academic consideration process. So you fill in some paperwork and then you write a deferred exam at some point. And again, your exam grade overrides all other grades. Right, so it is possible to take a 100% exam in this course this term. Any questions about the grading scheme? All right, super. What else do we want to talk about? So there's grading, the assignments. Okay, so the assignments are supposed to be done individually. They probably never are done individually, right? You submit them on OnQ. So I strongly encourage you to actually try to do them individually and not to feed the question to ChatGPT and hope that it spits out a suitable answer. The only way that you're going to learn how to program or how to program in this course is to actually sit down and do some programming, right? And just doing the 5 assignments probably isn't enough to actually become a reasonably good programmer by the end of this course. So I do strongly encourage you to attempt the assignments yourself. Yeah, so that you get some practice writing code. Tests, so again, they're in class, they're written. This is the other issue with with this type of course. A lot of the work that you'll be doing in the course, you'll be programming probably in some sort of integrated development environment. So either Visual Studio Code or Eclipse. Modern development environments do a lot of the work for you. So they will suggest code that you might want to use in this particular instance. Obviously, you can't do this during a test, right? You're not going to have Visual Studio Code telling, hey, maybe you should try writing your for loop like this. So you have to, when you're practicing for your tests, you have to practice them on pen and paper. Right? Sitting at your keyboard and typing in code to practice for your tests and exams, probably not a good strategy. And again, the exam is also in person. It's scheduled by the exams office. All right, any questions about administration of the course? Okay, so what the heck is this course about? All right, so this is your second, this should be your second or third course, programming course in computing science. And so in your previous two courses, one or two courses, you learned what you could call procedural programming, right? So you write a program, it has some information in it, so data, right? And then you perform operations on the data, probably by writing some functions. You pass the data to the functions do something to the data, they might return a result, right? So you break your program down into what are called functions or procedures. This is a course in object-oriented programming. So in object-oriented programming, you decompose your program in a different way. There are things that look like functions, but there are other things as well, right? There are these things called objects or classes that you use to organize your program. So this is an introductory course in object-oriented programming. The rest of this stuff, I mean, you can read that. It's not going to make any sense to you at this point in time if you've never done any of this stuff before. Right? Basically, you're going to learn about object-oriented programming. We're using a programming language called Java. Okay, so what the heck is object-oriented programming? So it's one of the most widely used programming paradigms. Right? And so in 121, you did something called procedural or structured programming. Right? You've got loops, if statements, and function calls. Depending on who taught you 121, you might have done a little bit of object-oriented programming in 121 as well. When you're using lists in 121, you might have been using them as objects, whether you know it or not, or whether you were told that or not. Right? Object-oriented programming, your program is made up of these things called objects, and the objects themselves, they carry the data in your program. So they have what's called state or information. And they have behavior, so they have methods. So you ask objects to do things for you when you write an object-oriented program. So your objects interact with one another by passing messages to one another. Right? So in other words, you can think of your objects as talking to one another. The way that they talk to one another is that they just call methods or functions belonging to the objects. If you progress through computing science as a degree, eventually you'll run into the course SYS 340, where you learn many, many other ways of writing a program or a piece of software. Right? There's many, many ways or many, many different programming paradigms that are used to create software. Object-oriented programming happens to be one of the most widely used in the real world right now, although that may change. All right, so we're using Java. So what the heck is Java? So Java is a general purpose cross-platform object-oriented programming language. So general purpose means it has no specific application in mind, right? So you can use it to write many different types of programs. Cross-platform means that you can target many different types of computer architectures. So it'll run on a Mac, it'll run in Windows, it'll run in Linux. Java is a bit unusual in that it runs in many, 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 many places. It was created in the early 1990s. So as a programming language, it's middle-aged. So it's not way back from the 70s when computer programming started to become very common. And it's not a very, very modern language that you might find today. Right? So its roots are in the 90s, and it was created to address issues with the dominant languages at the time. So those were C and C++, which are still the dominant languages of our time. So the most popular programming languages, excluding the stuff for the web, would be C, C++, Java, and Python, in some order. Right? The primary goals aren't super important for our purposes right now. All right, so where is Java used? So it turns out it's used in a lot of places. It more or less dominates what's called enterprise software. So this is the software that's written and used by very large organizations, lots and lots and lots of employees that have to exchange information across many, many different systems. Java is very commonly used there. A lot of the internet infrastructure software relies on some form of Java, right? Whether it's programmed in Java or it uses some sort of Java library, there is a strong dependence on Java software in server data. Sorry, in server-side applications. Big data is related to server-side stuff, so it's all more or less the same thing. Embedded devices, so these are devices that don't look like computers, but actually have a computer in them. Java shows up in many of these sort of devices, although C probably dominates this area. Some scientific applications do use Java. In particular, NASA, oddly enough, is a fairly large user of Java. And some video games are written in Java. So the first version of Minecraft was written in Java. When Microsoft bought it, they turned it over to C# or C++ or something. But there are some video games that are written in Java. Most of them are indie video games. They're not the big AAA video games. Those are probably written in C or C++. There's a link here if you want to see some of the cool software that's been written in Java. You'll see a lot of the applications here are applications that NASA uses. So one of the robots on Mars, the Mars Explorer, its software was written in Java, or part of its software was written in Java. All right, so we spent 1 or 2 courses teaching you Python, so you might ask, well, why don't we just keep on using Python? Because Python is also object-oriented if you want to use it that way. And so the answer is, well, it's good for you to learn many different types of languages. If you become a professional software developer, you will be continuously learning new languages, most likely. So this is an issue that you're not going to avoid just by sticking with one language. You're going to have to learn many different languages anyway. Eventually, in our computing program, many of the upper year courses use either C or C++, and it's much easier to learn C or C++ if you know Java rather than if you just know Python. So the core of the Java language is basically C. So it borrows a lot of the basic syntax from C. So it's much easier to transition to these languages in your upper year courses. And no one actually tries to, well, that's not true. You don't actually have many dedicated courses in your curriculum that actually teach you C and C++. Sys 220 teaches you a little bit of C. Sys 220 teaches you C. There's a 3rd year course that uses C++, but I don't think they actually try to teach you C++ in that course. I think they basically say, we're using C++, you have to learn how to use it and have fun. Right? And so this is your one chance where someone is going to teach you something that looks like C. Well, I wonder if you take Sys 220, you also learn some C. Okay, so you need to use Java in this course, and that means you're going to have to get access to a computer that lets you write Java code. So you can use CASLab if you want to, but there's like 300 of you, and I think there's only like 5 computers in CASLab, so that's not going to work. So most of you will probably want to install some sort of a Java development environment on your computer. Right? It's not very hard to do. Basically, you install something called a Java development kit. So Java updates 2 times every year. I think the current version is 23, so that you might as well just install that one. It doesn't really matter which version of Java you install. Anything greater than 8 will be sufficient for this course. You also need some programming environment to help you write your Java code. So the one that we use in this course is Eclipse. It's how I provide all of your assignments. So it shows up in what's called an Eclipse an Eclipse project archive. But you don't have to use Eclipse if you don't want to. You can use NetBeans if you like. A lot of people like NetBeans. You can use Visual Studio Code if you like. Or any other Java development environment, as long as you can get the assignments into the development environment. Right? But I provide everything to you in Eclipse. Instructions are on OnCue for installing all of this stuff. Now, I haven't double-checked the instructions for this term, so I don't know if they are going to work exactly the same way as how the videos walk you through installing the software. Where'd it go? It's under content, course readings and resources. So for Mac OS, there's a link here. For Windows, there's a link here. Installing the stuff, basically there's a graphical installer for both operating systems. So you can just install Java using install. So download Java, download Eclipse, install. There's some videos that walk you through the process. The videos are a little old now, so they're 2 or 3 years old. They should be more or less the same. The process should be more or less the same. And the process is more or less the same for both Windows and Mac. All right, so you're going to want to get that set up sometime this week. Right? So your first assignment will show up either towards the end of this week or the beginning of next week. Okay, so earlier I mentioned that there are a bunch of notebooks, there was a textbook that was written for this course, and that's true. So if you go back to OnCue and you go to the lectures section, so under content, lectures, and lecture files, you will find a big table of all the lectures in the course. This has to be updated. Some of these are crossed out, and that was from last term. I just copied the OnCue over from last term. So I'm going to have to uncross these out and update this page. But the first few lectures are all up to date. So there is a static version of the online notes on my GitHub. So if you open up this link, oh, I already have it open up here. Right. So if you go to my GitHub, you will find, you follow that link, you'll find a link to the course notes. And so this is the table of contents, right? Each blue piece of text is a link to another notebook. You can see there's lots of notebooks. Last term, we didn't get through all of the material here. So basically last term, we ended up somewhere around here. But we do cover most of the material that's in these books. So if you click on the link, this basically looks like a traditional online notebook, right? So it's got a bunch of text, it's got some code, yada, yada, yada. Right. There's also a live version or an interactive version of these notes. So if you follow this link, you can go here. Now the problem with this is that, okay. So hopefully this works. All right, so what's going on here is that it's the same set of notebooks I just showed you, except the code that's in them, you can actually run them in your web browser. Java was never meant to do this. You were never meant to run Java code in your web browser directly. And so the technology underpinning all of this is fairly sophisticated. So this is using something called Jupyter Notebooks. If you do any sort of machine learning or AI stuff, you're probably going to encounter Jupyter Notebooks in some form. So it's a fairly recent technology that's become very popular for distributing code. Well, the reason why it's become so popular is because you can distribute code in something that looks like a web page and it actually runs in the web page. And you can see here that this is not super reliable. So the problem with the notebooks is that they're a little bit older now. The technology, so they were written 5 years ago now, 4 or 5 years ago now. And all the software that's used to write them, it all evolves very rapidly. And so I'm having trouble keeping it up to date. And you can see here that it's refusing to load this web page. So the more people that use the notebooks, the faster this process becomes. I'm going to try closing it and opening it up again. Hopefully this works. If it doesn't work, that's also fine. It was working earlier this morning when I tried it. But so what's going on is that the notebooks are being hosted by somebody somewhere else in the world for free. And so there is this service called Binder that lets you host Jupyter Notebooks. And it runs on a bunch of servers somewhere in the world where people have donated server time for these notebooks to run. So they're not running, for example, on some Queen's University computer somewhere. I think we're going to be out of luck this morning and they're not going to run for me. Anyway, that's fine. So I'm just going to move on. Hopefully I'm going to wait, we'll wait a minute to see if they actually load. But even if they don't, that's fine. All right, so you've got a bunch of notebooks that you can use if you want to. The notebooks they contain a lot more detail than I cover in the lectures. The only thing that you're tested on is what's in the lectures, right? And so it's not a requirement that you actually read the notebooks. They're there for you to explore the material in greater detail. And also, if you need additional explanation of how things are, of why things work the way they do, you can probably find it in the notebooks. All right, so in the interactive version of the notebooks, you'll come across code that looks something like this. Right? So here you can see a little snippet of Python code that prints hello world. In the interactive version of the notebooks, you can actually run this piece of code in the notebook. So if you click on the run button here, it will actually print hello world underneath this box. Yeah, I think we're out of luck this morning. Right. And so this will run some Python code. Inside all of the notebooks, almost all of the notebooks, there are a bunch of exercises that are embedded in the notebooks. Right? And so this exercise here says edit the code in the cell above so that it prints something else. So you would go into this code cell up here, edit it, and change the way that it works and see what happens. All right, this is not going to work, so let's show you how you do this, how you actually write a Java program. So this is Eclipse. So this is the IDE that we use in the course. And this is what this is what the hello world program looks like in Java, right? So now, you know hello world in Python, you can write it in just one line, right? So notice that in Java, you have to write a lot more code, right? So the first thing you're going to notice is that there's this funny line up here that says public class hello world, right? And so in Java, all your code lives in what's called a class, right? Or class, more properly, it lives in multiple classes. So you can't just write print hello world. That's not going to work in Java, right? You actually need a class to put your code in. So there's my class, right? Now remember in Python, you use indentation to indicate blocks of code. Java is one of these brace delimited languages, so it uses braces. So an opening brace and a closing brace to delimit blocks of code, right? And so this is one of the things you're going to have to get used to very quickly. Indentation in Java doesn't really matter. The software that reads your code doesn't care about indentation, right? Whereas the software that reads your code in Python very much cares about indentation. Instead, we're using braces. So once you've got your class created, you still can't write just print hello world. You now need something that looks like this. So here we've got public static void main, and then string, square brackets, and args. Which looks like a mess, and that's because it is a bit of a mess, frankly. So in Java, every program that runs, that you want to run, starts in what's called a method called main, right? So a method is like a function, are like functions that you learned about in Python. The difference between a function and a method is that a method lives inside of a class, right? Or belongs to an object. So here the main method is inside the class, hello world, right? Your main method has to look like that. And I'll explain more about this in the next lecture, right? Finally, that's how you print something in Java, right? Notice it's not just print, it's system.out.println, and then round brackets, and then some braces, then some quotes, and then hello world. Oh, and then also notice the semicolon at the end of the line. Semicolon is important. So lines of code in Java almost always end with a semicolon. Okay, so once you've got your program written, you can finally run it, right? And so in Eclipse, there's a little green button up here. You might have a hard time seeing it. It's a little green play button up here, right? So if you press the play button there, this code will run. It'll output the contents in the console below, and there you see hello world. All right, so if you go into this program here and you start fiddling around with it, so if I delete a brace, for example, and save my work, and then try to run it again, right, you'll get an error down here. Right, so you get some sort of error message complaining about something is wrong with your program, right? This one seems to be complaining that there's a missing brace, so I guess we should put that back in, right? If you delete a semicolon, save your work. Right? It's also going to, and try to run it, it will also complain, right? Again, unresolved compilation problem, insert a semicolon to fix your problem. All right, so what the heck is this unresolved compilation problem? So Java is a compiled program. Python, so in Python, when you learned how to use Python, you were probably told it's an interpreted language, right? So in other words, there is some program that reads your Python code and then runs it natively. Java doesn't work that way. So Java is a compiled language. So before you can run your program, you need to feed your Java program to something called a compiler. The compiler reads your program, turns it into some other, converts it into some other format, and that other format can then be run. Right? So what you used to do to write a Java program is you would do the following. So I'm going to pop open a command line interface here. I'm just going to show you, what is it called? So I just made this, here it is. So okay, so there's hello world. It's a little bit different, right? Notice that the name of the class is called my class instead of hello world. But otherwise, everything's the same. So to create a Java program, what you do is you create a text file that contains the contents of your code, and then you have to compile it. So most of you won't be able to do this on your computers the way they currently are. I can because I have all the software I need installed. So what I need to do is I need to feed this program to a compiler. And the standard compiler for Java is called JavaC. So I'm going to try to compile my program here. Right? In this case, it didn't work. We have an error. Right? So here we've got this error. It says my class is public, should be declared in the file myclass.java. And so this is another difference between Java and Python. The name of the class, my class, right, has to match the name of the file that it's in. Right? And so the name of my file is hello world. So I either have to change the class name or the file name. So in this case, I'm going to change the class name. So I have to change my class to hello world. So I'm going to go into my file. I'm going to change my class to hello world. Case is important in Java, right? So big H, big W is different than little h, little w here. Did I get that right? Okay. So once I've got that completed, I can then go ahead and try to compile my program again. In this case, it works, right? And so Java is a compiled language. You have to feed your program into a compiler. The compiler reads your program, determines if it's syntactically correct, turns it into something else, right? So the something else that it turns it into is this other file called helloworld.class, right? And it's this file here that can be run by the Java virtual machine. So now if I run hello world, I actually get the contents hello world. Fortunately, you don't have to do this anymore, right? So you don't have to go into a command line interface and then run the compiler yourself and then look at the compiler output and determine whether or not you have to fix your program or not. Right? Nowadays, we've got these lovely tools like Eclipse or Visual Studio Code that does all this for you. So when you're pressing that play button, what's actually happening is Eclipse is taking your program, it's feeding it to the compiler. It's looking at the compiler output to determine whether or not the compilation process succeeds. And then if it does succeed, it actually runs your program. Right? And so all of that, all of those steps that you used to have to do yourself, most integrated development environments do for you nowadays. Right? And so there is a little example of how to create the Hello World program. So once you've got your software installed, oh, hey, it worked. Okay, so I'll show you this. Let's try looking here. Perfect. All right. So let me just clean this up a bit. I just want to get rid of the header and the menu bar here so that we can see the code a little bit easier. Okay, and get rid of this. Okay, thank you. All right. Oh. Sure. There we go. All right, so the online version of the interactive versions of the notes, as I mentioned, they've got these gray cells in them that contain code. The code is runnable. So on my computer here, you get this little play button beside the code cell. So if I click on that and you wait a few seconds, this will eventually run the code that's there. So the first time you do this, it's normally a little bit slow. After that, it becomes a little bit faster. So here you get hello world. The notebooks are interactive, which means you can go into the code cell and edit it yourself. Right? If you edit it, you don't have to worry about, so you're not going to save it. So remember, this is running on somebody else's computer. So whatever edits you make, whoever else is using the notebooks, they don't see the same edit, right? You get your own independent version of the book, right? So you can edit it, go ahead and run it, and now you get that, right? All the notebooks contain exercises for you. So here, we just did exercise number 1, right? It also tells you exercise number 2, go ahead and change that code so that it contains an error, so I can delete the bracket and run that. And you'll see that now you get some sort of error. This is a similar error that you would get from the Python interpreter if you were to write that into the interpreter. Okay, so here's hello world in Java, right? I think we'll all agree it looks more or less the same except for the ... here, right? If I run this, again, you wait a few seconds, and then it spits out null, right? So it doesn't print out hello world, right? Which looks funny. So what's actually happened here is that when you run this code cell, the Java compiler compiles this code. So remember, the compiler runs, all it does is take this code and convert it into something else, right? So to actually run this code, you have to call the main method. And so down here, I can actually call the main method, and now I actually get hello world to spit out. This is a little bit awkward to do, but we'll fix this in just a second. Okay, so the same exercise here, you can go into this code cell, you can go ahead and change it yourself. So this 124, right? You can rerun it. Then I have to rerun this one as well. Okay, so that's great. If I make a mistake, so if I forget the semicolon and I compile that, you get your compiler error up here, right? So it tells you, hey, you're missing a semicolon, so you go and fix semicolon, right? Rerun it to recompile, right? Rerun the next cell, and that runs again, right? And so all of your notebooks look something like this. They contain a bunch of code. They contain a bunch of information, probably too much, frankly. They contain a bunch of code cells in it, which you can run and edit. And then they contain a bunch of exercises as well. So the rest of the notebooks, you don't have to run 2 cells to get some output. So let's look at another notebook. So let's just jump to, I don't know, how about the integer types and see what we have here. So I've just jumped forward to some random notebook. So this talks about integer values in Java. Right, so again, notice code cell, which you can run. Again, the first time you run a code cell, it normally takes a little while. Okay, so there we go. So we've just computed 1 Google in Python, right? 10 raised to the power 100. Right, and you can do some other stuff here too as well, and more stuff here, and more stuff here, right? And then in Java, there's some code cells here, which you can also run. Right, here we're just doing, we're making a variable x whose value is 0 and then changing the value x a few times. Okay, so this is one of the problems with the technology that was used to write these notebooks. So the technology that was used has evolved over the years. And so the way these notebooks were originally written, this shouldn't have printed anything, right? So if you look at the code that's here, all that we have is this variable x. Right, and we assign x 0, minus 0, 100, and minus 99. That's all it does, right? We don't print out the value at all. However, when you run this, you actually get out the value minus 99, which is unfortunate because if you were to put this code into Eclipse, you would not get this output. So I'm going to paste that into my program up here. I'm just going to overwrite this like that. Right, so that's the exact same code that was in the code cell, except it's now in a main method. So if I run this, you're going to get no output, which is what you should get, right? There's no system.out.println line here. Nothing should be printed to the output. So the problem that's happened is that relatively recently, by that I mean a couple of years ago, Java made a change to the language. They inserted something called a REPL. So it's basically they put something into the Java language that lets you write pieces of Java code, so an incomplete Java program that you could now run. And the default behavior of that is to print out the value of the last statement. right? So the value of that last statement, it turns out, is minus 99, so it prints out that statement. And so the output that you get in the code cells isn't always what you're going to get when you run it in an actual Java program, which is a little bit unfortunate. There's nothing I can do about that, unfortunately. All right, so every notebook's got a bunch of exercises in them. They're scattered throughout the notebook. I think this one's all the way at the end, right? You can actually do the exercises in the notebook itself, right? If you want to, you can copy everything from you can copy the code or run the code in Eclipse instead if you'd like. Right? So there's lots of exercises available to you in the notebooks themselves. Now, one of the complaints you often get from students is that you've given us all these exercises, but you didn't tell us what the answers are. Inside every part, so the notebooks are broken up into 4 major parts. Right? At the end of every major part are the answers to all the exercises. Right? So that was the integer notebook, so I just have to find the integer notebook. Oh, sorry. Somewhere. Here. Right? So if you go to the integer notebook section, you will find the answers for all of the exercises in the notebooks. So if you're looking for extra exercises to do, there are lots of them in the notebooks themselves. You can also find, if you also go and find a Java textbook, you will probably find some exercises in those textbooks as well. And of course, there's also the assignments that you'll be doing during the term. But again, the only way that you're actually going to learn how to program in any programming language is to actually sit down and do some programming. So I would suggest that at a minimum you do the assignments, right? And if you want to, or if you need to do well in this course to enroll in a computing plan, you're probably going to have to do extra work as well, right? You're probably going to have to work through the exercises or find some other way to practice programming in the Java language. All right. That's all I want to talk about today. Does anybody have any questions about the course? If not, I will see you again, I guess, on Wednesday? Thursday, I don't know, sometime later this week.